Well, then, we are live with episode 56 of Space Rocks Uplink. And, well, it's going to be an exciting one because there's so much that's happening next week as well. I'm just going to bring Mark McCorkin in and see if he's receiving and make sure my camera's working as well. Okay, here we go. Mark, how are you doing?
I'm good.
Nice to see you again.
And you, Alex, and you as ever.
Indeed. Well, my cat's just entered the room, and so it must be time for Uplink. We'll just be hearing sounds of Angus as the night goes on. And Mark, I was just commenting, sometimes we do very topical episodes, and sometimes we talk about things that are about to happen. But I don't think there's ever been a moment where so much has been about to happen in almost, well, vaguely exactly the same space. Now, what is going to happen next week exactly? Because I mean, it's still kind of blowing my mind.
Yeah, so you could see behind me a picture of Venus, actually taken by the Japanese satellite called Akatsuki. Let me just move that light a little bit. A couple of years ago. So there's an orbiter there at Venus, and we've had missions there in the past, Venus Express. There have been other missions that have gone to the surface of Venus, the atmosphere of Venus. But this time, next week, we're actually using Venus as a way station, as a place to go to grab some gravity, to get the gravity to help us fly by and change the trajectory of these two spacecraft. So on this side, this is BepiColombo, which is launched in October 2018, European Space Agency collaboration with the Japanese Space Agency, JAXA. And on this side, Solar Orbiter, which was launched in February last year, 2020. And that's a collaboration between European Space Agency and NASA. And they're both converging right now. They're a few million kilometers out as we speak, as we're live streaming. They're a few million kilometers out from Venus, but they will be flying very close to Venus on the 9th and 10th of August, so next week. Solar Orbiter will be going about 8,000 kilometers above the surface in the early hours of the morning on the 9th of August. And then BepiColombo will be flying past 33 hours later in the afternoon in Europe of the 10th of August, just 550 kilometers above the surface of Venus. And then they will go on from there. That's not their destination. It's a place where they're using the gravity to get an assist and change their trajectories. BepiColombo is on its way to Mercury, and it'll be there later this year. And Solar Orbiter is investigating the sun, and it'll come back to Venus several times in the next years. So that's what's happening next week, and that's what we want to talk about this evening.
Indeed. And, I can't think of two better people in the universe than Joe Zender and Lina Hadid to tell us all about what's going to happen and why it's so important. So, I mean, could you run us through a bit of their CV?
Yeah, absolutely. So Joe is a colleague of mine at the European Space Agency. He is the Deputy Project Scientist for BepiColombo. We've had the Project Scientist on before, Johannes Benkoff. Joe Zender's coming on this evening. And we've had the spacecraft operation manager, Elsa Montignon. She's actually now changed roles in the last few months. She's now the mission manager for BepiColombo. So Joe is all over these flybys and the cruise phase, as we call it, for BepiColombo, as it first had an Earth flyby, 2 Venus flybys, and now the Mercury flybys, which will start happening later this year. So he can tell us about the operations and the science of that's going to be happening with Bepi. And what happens when we get to Mercury. And our other guest this evening is Lina Hadid. And Lina is a plasma physicist. And I've already asked her to explain that to everybody. I know maybe Matt Taylor's watching this evening. He knows what plasma is, but not everybody does. And Lina, actually, she's a plasma physicist at an institute, the Laboratoire de Physique des Plasmas in Paris. But she used to work for us. She used to be a research fellow at ESTEC, just up the road from where I am now. And she's been coordinating the scientific work that will be done by Solar Orbiter, which is our solar mission, and by BepiColombo during this near joint flyby. So she'll be telling us what we can actually do meaningfully, scientifically, when we fly past Venus. We're not just using it as a gravity assist, we're going to do some science there as well.
Indeed, and I think that's something that's so interesting, which is why it's probably the moment to bring them into the chat. And I'm so excited about this, of course, because I think that well, beyond the science, just the complexity of what's going on, and I think that we've got Lina and Joe joining. Although I've got a sneaking suspicion that Lina might actually be watching the YouTube channel,
or somebody's watching YouTube with the
Joe,
delay.
Yeah, indeed. I've just muted and unmuted, and there we go. Okay, and then we're there. How you doing, Joe? Are you receiving?
Yes, I'm here. Good evening.
Okay.
Hi, Joe.
Fantastic. And Lina, if you just, I've just temporarily just asked you to unmute, and we will begin the show. Okay. It is a live one, and so this is a natural thing.
Sorry.
Fantastic. Are you receiving? Okay.
Yeah.
Fantastic. Well, guys, girls, this is an absolutely fantastic moment to be talking about this. What's happening next week just completely blows my mind. And, I've got to say, I'm going to take, a wild guess that is a lot more complex than what it sounds. And we're going to be getting to that, of course. But as Mark just said, this is more than a gravity assist. It's more than a slingshot around Venus. Lina, what's going to be going on from a science perspective? What are we hoping to learn?
Yeah, so in fact, so as Mark has explained, so we will have the Venus flyby with BepiColombo and Solar Orbiter. So it's a very special flyby of Venus. Well, it's not the first time that BepiColombo and Solar Orbiter have flew by Venus. In fact, so the first BepiColombo flyby was on the 15th of October, 2020, and for Solar Orbiter, it was in December 2020. So it was from these two first flybys, we had very exciting observations of the induced magnetosphere of Venus, of the environments of Venus itself. So from the combined in situ measurements and remote sensing measurements, at least on BepiColombo and on Solar Orbiter, we could characterize the global structure of, let's say, the magnetic bubble that we call magnetosphere of Venus, but also to study more in detail all the physical processes. And I mean, as you said, Venus, it's not the first time that we've visited Venus, but we, if the tail region of the planet has not been investigated very much, and from the orbit trajectory that, well, maybe we can talk about later, we will spend a lot of time in the tail region, and so we will be making very interesting observations and measurements.
So Joe, let's bring you in here, because they're not going to exactly the same place. It's not as if there's a door that you go through and say, I've done a flyby. Solar Orbiter and BepiColombo going to quite different altitudes above the surface, as I mentioned.
Exactly. So exactly. So for this second flyby, so both spacecraft will fly or approach Venus from the night side towards day side, but the trajectory is not exactly the same. So both of them, they will be located in different regions at different times. And BepiColombo will approach Venus at about 550 kilometers from the surface, which is much lower than the first flyby that we had. And yeah, this is very exciting. And also Solar Orbiter would be about 8,000 kilometers. So for the first time, we will be having 2-point measurements around Venus. So that's very, very exciting.
Right. So Joe, we have two spacecraft which are not designed for Venus at all. They're not. That's not where they were. It's not where they're going. It's not what they're doing. And in fact, because of that, we can't turn on all the science instruments on the two spacecraft. So talk us through that. What can we and what can't we do? So first with BepiColombo and with Solar Orbiter. And I know you're the Bepi expert, of course, but so tell us why we can't turn on all of the science cameras, for example, on BepiColombo.
Yeah. Okay, let's start at the point that initially we did not really prepare to operate any instruments during the cruise phase, not at the planetary flybys. But we got green light about a year before launch that, let's say, if everything is okay, if all the teams confirm that the instruments are safe to operate, if there's no danger for the long-term observations, if the resources are there on the spacecraft, but also on ground. So, I'm on vacation and I'm getting 1 hour here for Bepi, but I know that the ESA colleagues, they are working long hours these days and have to take their summer break earlier or later. So that was the first hurdle, actually. Do we have resources in space and on ground to do this? And it was confirmed. And so we're operating some of the instruments. But on BepiColombo, we are flying 3 different spacecraft. We have the transfer module. On top of the transfer module, we have the ESA provided spacecraft, the planetary orbiter. On top of this is the JAXA, the Japanese provided spacecraft, the MEO. And around the MEO is a safety shield, MOSIF, which is shielding the Japanese spacecraft from the solar wind. So this means for the MPO, for the planetary orbiter, the remote sensing instruments are mounted such that they are viewing basically towards the transfer module. So the only thing we can operate the remote sensing instruments is making the dark currents, so to say, right? And switching them on and off. That's all we can do until we release the spacecraft beginning of 2026. So having said this, we have still 2 remote sensing instruments. We have a spectrometer and an infrared imager which can operate. We have Mercurys, the infrared spectrometer, who has a calibration channel. It was designed such a way that when we observe the surface of Mercury, that there is a channel which we can use the calibration, so we can look at the stars to calibrate the instrument inside. So now this has the advantage now, if we bring this calibration channel towards Venus, which we're doing right now, also in the last days, so we get infrared spectra from Venus. Then we have a UV spectrometer, which is mounted such that it has a baffle which can rotate 360 degrees, so quite a lot of flexibility. And also Phoebus is doing observations right now. I say right now, I have in mind that we are at Flyby. The Flyby is next week, which will operate before Flyby and then also after the closest Flyby. We have other instruments. We have in situ instruments who are fully deployed. For example, the magnetometer is fully operational and they are observing during the cruise phase and also now during the flyby. We have 2 detectors on the Serena suite, which can operate, where we're measuring ions and neutrals. And we have an X-ray spectrometer, which is sitting on top of the MPO and looking in one direction, which is also operated. Let me see, probably have forgotten a lot.
Well, you've forgotten the cameras, but we'll come back to that a bit later on.
Oh yeah, the cameras, which is kind of our baby here. Yeah. But let me see, maybe to mention, there are 2, one experiment, one instrument, which are typically not mentioned in this kind of activities. So we have the radio science experiment, which is also operating at one point, and the ESA, which is a spring accelerometer, which I probably come back later on to tell a little story about this, because it's a very interesting instrument, and they are also operating during the flyby.
Right. So Lina, the one thing, because Joe has already dumped a lot of acronyms on us, we're going to have to dig into. But let's talk about plasma, because this is one thing that both missions are designed to do, that both missions have most of their instruments deployed, what we call in situ, which is measuring the stuff around you rather than looking at something remotely. What the hell is plasma? Tell the audience what plasma is and why we care. Right.
Plasma is the ionized gas. It's an ionized gas, and is
okay. Now I'm just going to really rip you all the way back for our audience. Ionized gas. Tell me what that means.
So we know that there's a different state of matters. So gas, liquid, and solid, and also there's a 4th state of matters, which is plasma, called plasma, and it's an ionized gas. So
that means you rip the electrons off
exactly.
the protons and neutrons, and this usually requires a lot of temperature or something else going on, right? It's not something you see on the Earth very much.
Well, we see it on Earth when there is, for instance, the thunderstorms. We see the effect of the plasma, but really it's not much common as in space. In space, we say that 99% of matter is space. Well, visible matter is made of plasma, and this plasma is ejected continuously from the sun, forming what is called the solar wind. So there is a kind of plasma which is ejected from the sun continuously towards the planets, and it hits the planets. Well, on Earth, we don't feel directly the effects of the solar wind because we are protected by our own magnetic field. So that forms the magnetic bubble or the magnetosphere that we call. But we see the effects from the auroras indirectly. However, on different planets like Venus, for instance, which does not have a magnetic field, well, it does not have its own magnetic field, the solar wind or the solar wind plasma, it directly interacts with the planets or the atmosphere of the planet, and well, there's the magnetic field as well in space. So there's a particles, the plasma, which is tangled with the magnetic field, and both they interact with the planet, and so they affect directly all the dynamical processes and the structure of this magnetic bubble or the cocoon, magnetic cocoon at Venus. And so.
Yeah. So before I hand back to Alex, just so tell us what can we do there with that plasma around Venus?
Yeah. So
how do we measure it? What are the sort of techniques we use?
So when we say in situ measurement, as you said, is we measure directly inside, so in situ the plasma around us, and with BepiColombo and Solar Orbiter for these next flybys, most of the in situ instruments will be on. For Solar Orbiter, all the in situ instruments will be on. So the particle experiments that will measure directly the electrons, the ions, and the ion composition as well. And also we will have measurements of the magnetic field. So we will be able to characterize, because when we measure the magnetic field from the different orientation and rotation of the magnetic field that we measure, we can characterize the global structure of the environment around Venus. And also when we measure the particles as well, we can know the ion composition and the different distributions of the particles that can give us ideas about different dynamical processes and waves around the environment.
Okay.
Well, it's a fascinating conjunction, but I wonder, it's been commented on the YouTube channel as well, it's a bit of a space traffic jam. Joe, I mean, how often does something like this happen, this conjunction? I know something of, kind of windows and so on, but this does seem like a unique precedent to me, or has it happened before?
Yes, indeed. I think it's not really traffic jam, I would say. There's a massive space available up there. But indeed, it's extraordinary what is happening right now, that we have 3 spacecraft around Venus next week, basically, right? We have a Japanese spacecraft from the Japanese space agency Akatsuki, which is orbiting Venus since several years. We have Solar Orbiter flying along, BepiColombo flying along. We have Parker Solar Probe, not in the vicinity of Venus, but in the inner solar system. So it's a huge opportunity for scientists to gather a lot of information from the inner solar system to understand the physics from the sun towards the Earth and even to the outer planets. So for many, many years, we had, let's say, spacecraft around Mars, then we had Venus Express around Venus, and we had Messenger at Mercury, but we always had single point measurements there, right? And once you are in orbit, you cannot measure the solar wind itself, you basically, that's an interesting point why we fly 2 spacecraft to Mercury. If you are in an orbit, you're not really sure often, do you measure the solar wind or do you measure the magnetic field in the case of Mercury, for example, or do you measure something in between, some border crossings or whatever? Therefore, if you have two spacecraft, you have two measurement points. This is very good to disentangle the solar wind from what the planet itself does. But now we have several spacecraft in the inner solar system, so we can do a lot of very nice observations, not only during the flybys, but during the whole of the cruise phase.
So again, I think the thing that people need to take away from this is that if you have a camera or a telescope, you take a picture of something, and maybe you might take it from two different angles, you might make it stereo, but with something you're feeling around you, you would only know what's happening here. If you want to connect the bigger picture together, you need multiple spacecraft. And we have that around the Earth. We have the cluster mission, which is 4 spacecraft orbiting around Earth, slightly different distances and so on, and they sense the magnetic field and the particles, and you can join the picture up. And the same lower down is with the swarm mission as well. And then you can add those two together. You can have swarm and cluster work together. So as you say, this is the first time we've had the opportunity to be at Venus with 2 spacecraft with these very advanced instruments, because these are brand new spacecraft, and have Parker Solar Probe there. But Lina, tell us what might be interesting about Venus. I mean, we've been to Venus loads of times, right? I mean, we're going to go back with new missions, but don't we know everything about Venus at this point? I mean, what are the kind of scientific questions about this? Because it's a planet with a crazy dense atmosphere, right? It's not the same as Mercury. It's not the same as Mars. It's kind of more like the Earth, but much thicker atmosphere than the Earth. So tell us a bit about Venus and what we can hope to understand.
So, I'm not a big expert on Venus, but from what I know, I mean, the big questions, Venus, we say it's a twin planet to Earth. It's very similar to Earth. It's a terrestrial planet with the same about size, same mass, but it has an extremely dense atmosphere from carbon dioxide and clouds of sulfuric acid. And it does not have a magnetic field. So from the big question is that, well, there are some theories about why Venus does not have a magnetic field, but we don't really know till now why. And and also whether, I think one of the other questions is that, is there any tectonic activities or volcanic activities on Venus as well? So it has been visited a lot, a long time ago until now, but we still don't really know. We don't have answers to many questions. And it's becoming a hot topic as well.
So this business of the magnetic field, let's talk about that a bit, because of course it's important to Mercury as well, this question. The Earth has a magnetic field which is due to the fact that it's got a liquid iron core, or it's got molten iron, and that rotates at a different speed to the Earth, the bit we're sitting on. And that makes a dynamo, and that creates a magnetic field. So the question is, why has Venus not got one of those if it's a planet like the Earth? But so Joe, let's jump to you for a second. You know, Mercury does have one, even though it's a much smaller planet, and we thought maybe Mercury's liquid core should have frozen by now or solidified. And this is one of the big topics for BepiColombo, isn't it? Looking at the magnetic field when we get to Mercury. So that's on you. Indeed. That's on you, Joe. Yeah.
You know, on let's say many years ago, it was, I think, clear to everybody that Mercury is a rock body, right? In the 50s, 60s, and there's no real reason to go to. I still do not understand why they mounted the magnetometer on the Mariner spacecraft, but they did. And to their surprise, they found that Mercury has a magnetic field, right? I still have to find books to say, why did they do this, right? Because we did not, nobody, I think, at this time did expect. So it was clear Mercury has a magnetic field. The NASA did send the Messenger spacecraft to Mercury, which was orbiting 2011 to 2015 around Mercury with a magnetometer. And they measured the magnetic field. And their basic result is twofold. They're saying the magnetic field has an offset northwards along the rotation axis, which we don't really understand, right? So when they came back with this result, they're saying, you know, we have a magnetic field, but it's shifted north. So now all the modelers are going back to their models and trying to see how can this be. it's an indication. So Mercury has many challenges, and we often call them the Mercury mysteries. It's an indication that in the core, something is different than what we think it is there, right? There are many other surprises. We don't see iron on the surface, right? And it could be that there is no iron in the core, right? Which could explain that this fluid in the fluid inner core is different than what we expect. Another surprise they're getting out is all of our models predict a magnetic field which is 100 times stronger than what we measure. So it's a big question, and we do not understand, not even from the modeling we can explain, right? There are different teams now all over the world who are analyzing, making different assumptions and trying to understand this. But it's a big question. And you might ask now, so why is this interesting? And I think the point here is the magnetic modeling is the modeling we're using on the Earth, right? Because the Earth is what we know. Here we can drill, right? Not in the core, but in the surface, right? We can do measurements. We can make tectonic observations and so on. So we built our knowledge of the model of the magnetosphere from the Earth. And at the same time, we are analyzing exoplanets, right? Hundreds and thousands of exoplanets where we are assuming our model also now to the exoplanets. However, we should be aware, and we are all aware, that Mercury, the innermost planet, gives us a different result. So it means our knowledge of the model we have currently of the interior of Mercury, but of the modeling of the dynamo of planets is not complete. And we hope with BepiColombo that we maybe, let's say, not want to say that we be solving the problem, but we approaching one step further. And there we have two magnetometers, very high precision magnetometers on both of the spacecraft, on the European one and on the Japanese one. Both spacecraft has been cross-calibrated together before the launch. The teams work very closely together. And to give you an idea, the spacecraft on the magnetosphere on Earth, I think if we measure is a few Tesla, right? I think 30 to 50 Tesla. With the magnetometers we are flying on BepiColombo, we can measure up to an accuracy of 0.2 nanotesla, right? Accuracy. So this is an extremely high accuracy that we're going to measure. I said the magnetic field is less strong than we expect, so we need a better accuracy. But we have wonderful instrumentation, in this case the magnetometers, which again have 2-point measurements. Because with 1-point measurements, as I said before, you don't really know where you are. So we have 2-point measurements, and with this we hope we get closer to the solution of the mystery of the magnetic field.
Well, this is fascinating stuff, and it's actually sparked some really great questions. In the chat, Jasmine asks, well, Lina, what do you mean Venus doesn't have a magnetosphere? And it's actually followed up by Martin says, is that uncommon? I suppose that's what we're discussing right now. I suppose, I don't know how we establish a baseline because we're still learning so much. But what are your thoughts?
Yeah, in fact, so I said, in fact, it has a magnetosphere, but it's not intrinsic magnetosphere like we have on Earth. We say that Venus has an induced magnetosphere. So the interplanetary magnetic field that will interact with the atmosphere of Venus, it will induce some magnetic field perturbation. And this magnetic field perturbation induces and forms what we call the induced magnetosphere. And so similarly to Earth as well, where we have large-scale boundaries around our magnetosphere, around Venus as well, we have a ball shock because of the very high speed, supersonic speed of the solar wind. And also there's a boundary between the shocked solar wind and the induced magnetosphere of Venus.
Hmm. So when you, for example, if we look at Mars is similar in the sense to Venus. It doesn't have its own magnetic field. It might have a bit of magnetic field locked into the crust. But because it doesn't have a magnetic field, that's a really important thing, right? Because it's about how life might survive on a planet like Mars. If you can't prevent all those high energy particles streaming through, because that protective bubble we have around Earth is important to life, isn't it? Now on Venus it's different, of course, because Venus has this incredibly thick atmosphere as well. But I think that goes to the second part of the question. Do we really have any kind of statistical idea whether Earth is the anomaly, or, we know that Jupiter has a big magnetic field, and some of the other planets do, but as a terrestrial planet, do we expect this to be common or uncommon, this magnetosphere that we have?
Well, it's a good question. I would say, I think is Venus, among all the planets, Venus and Mars are the only terrestrial planets that do not have a magnetic field.
Well, that's 2 out of 4. That's 50%. So that's
yeah, that's true. So I think it's well, Mars, maybe it had a magnetic field before. So then because of, well, I'm not sure what happened, but then it kind of disappeared, and we only see the anomalies now. But I think it's maybe in millions of years later, the magnetic field on Earth will disappear as well, and
yeah, that's interesting, isn't it? Because of course the Earth's magnetic field changes. It's not a constant thing either. It flips over. We know this happens on the sun. That's how we get the sunspot cycle. But just let's talk. I don't know much about magnetic fields and plasma. I should know more. But so on the Earth, how often does this happen? These flips. Roughly speaking, I don't want to put you on the spot. It's not an exam, but it's not every 22 years, right?
No, it's on scales of, I don't know, hundreds, millions of years. It's, fortunately for us, I would say that we don't really feel this really flipping of the magnetic fields. Because this would affect all the coupling. The coupling of the solar wind with the planets and the habitability of the planets as well. Everything will be affected. So, the last time it happened, I would say it was, maybe Joe can correct me, but like order of millions of.
Oh, Joe's not that much older than you. Come on, let's be fair. That's a bit rude. Yeah, Joe, honestly, you would know you're old enough.
I would also have to check on Google, honestly. Yeah.
One of the things, this is just a little anecdote. So a few years ago, before I joined ESA, I used to go each year on a sabbatical to the University of Cambridge because I had some collaborators there. And in one of the years I was there, we rented a house, and the owner of the house, who was a lecturer but working in Germany, her father is a guy called Teddy Bullard. And Teddy Bullard worked in Cambridge in the oceanography I'm going to guess in the middle of the 20th century. And they went out to the mid-Atlantic ridge, which is a point where the continental plates are moving apart. We talked about plate tectonics a bit, and of course we kind of know that South America and Africa kind of joined up at some point in the past, and now they're moving apart. And he measured the magnetic field there in the mid-Atlantic ridge, and you can see stripes of the magnetic field changing from one polarity to the other as you move away from the ridge. And that's how we know how often the pole flips, because you know the speed at which the mid-Atlantic ridge is growing in kind of centimeters per year, and then you see, well, it's 10 kilometers, it's 100 kilometers, and that allows you to time, and I can't remember the number either, but I think it's hundreds of thousands or maybe millions of years as well. But that's a sort of fascinating measurement, isn't it? You can just go and measure the stripes of magnetic field moving on the planet Earth.
Yeah, in fact, if I'm not...
Mark, there are...
Lina, you go first.
Yeah, I was going to say that if I'm not wrong, one of the reasons we think that Venus does not have a magnetic field, it's the lack of the convection, and this is due that, there's no heat transfer from the core towards,
This is convection from the planetary core up to the surface. Right.
Yeah, and because we don't have that because of the lack of tectonic activity as well on Venus. So this is related to what you were saying.
Yeah. Sorry, Joe. Go ahead.
Please.
No, I was just saying there's even a more near example that if the archaeologists, when they're finding pottery somewhere in caves, they are dating them by analyzing the baked-in magnetic field. And that's very interesting. And basically, we might be able to do something like this also on Mercury. However, we have to be very close to the surface. So with our standard orbit, where we are flying between 400 and 1500 kilometers, we are measuring the magnetic field of Mercury. But at one time, maybe at the end of life of Mercury, when we're going below 100 kilometers, we could measure the baked-in magnetic field of the rocks which are there off the surface, which would give us new information about the age of the surface. Or so that's to come in the future.
Indeed. Fascinating archaeological technique, certainly. Something that one of our other guests tonight, Matt Taylor, has joined us and he says it's an interesting point to be made about atmospheric escape from magnetized and non-magnetized planets. I suppose a question for the group, what's he talking about?
Lina, you go for that one first. Yeah.
So it's the atmospheric when at Earth, because we are protected by the magnetic field, the ions are kind of embedded inside the magnetosphere because there's the magnetic field around. But at Mars or Venus, the particles, when the solar wind hits the planets, first it stripped away ions from the solar wind into the atmosphere of the planets, such as Venus, but also it takes away as well ions from the atmosphere towards the night side and tailward. So the particles escapes from the magnetosphere of the planet when we don't have a magnetic field around.
May I add something there? Hi, Matt. So Matt is coming from comets from Rosetta, where we all know the comets, they have a tail, right? If you Google quickly, everybody listening, to Mercury sodium tail on Google, you will find in the first or second hit wonderful images of the sodium tail of Mercury. So actually, if you're observing Mercury from Earth or from space with a sodium filter, you see a tail, and I'm not meaning just something small. I mean a really elongated tail out in the solar system, originating from Mercury. So one of the questions on Mercury is, how in the hell can it be that we have volatiles, so much volatiles on Mercury? And it's not only we know we can measure sodium, but we know that there is magnesium, calcium, oxygen, and many other elements which the planet is releasing, right? Or first producing and then releasing. And we do not really understand the mechanism on Mercury, how this is happening. So we have a magnetic field, which is playing a role there, right? But it could also be that the bombardment by micrometeorites, the solar energy interacting with the surface, or activities below the surface, which are then releasing volatiles, could cause this, or most likely an interaction of all of this.
So let's step back a second. When you say volatiles, we mean very light elements, things that should be easily driven off the surface by the intense heat of the sun. Because remind us again, how hot does the surface of Mercury get? On the day side, of course.
On the day side, we have temperatures up to 400 to 450 degrees Celsius.
Yeah. So that means if you had any light elements like sulfur or oxygen and so on the surface, that amount of heat, they just escape into space. And yet we see that stuff coming off still now. So something must be making it today, right? It's that kind of timescale problem. It was obviously there in the beginning, but it should all have been baked off now. And yet it's coming from somewhere.
One would assume, but there is activity on the Mercury surface with the exosphere, with the subsurface, which is making this.
I mean, one of the interesting things to me always about Mercury is the fact that it has this very strange day-night cycle, right, with respect to its year. It rotates very slowly, but it's in a resonance with its orbital period. So I can't remember who wrote it now, and whoever did, please let me know. But the science fiction novel where you could actually almost walk in front of the Terminator, the day-night cycle, because you don't want to be caught on the day side of Mercury. That's not a good idea. But you can maybe, if you can wander along and watch all the lovely sunrises over the mountains and stay out of the direct sunlight, you could survive. But how does that play a role in the evolution of Mercury, the geology of Mercury? Because I'm also thinking about the rotation axis of Mercury and the fact that it's very straight, right? It's very orthogonal, 90 degrees to the solar, where our Earth is 23.5 degrees. That makes for something quite special at the poles of Mercury, doesn't it?
Yeah, honestly, I'm not now sure really what the effect of this 2 to 3 resonance of the year and the Mercury day, what the impact is on the evolution of Mercury. Honestly, I don't know.
I mean, let's be clear. Every point on the surface of Mercury, below a certain latitude, gets to see sunlight, right? So but at the poles, I kind of led you down the garden path. I want to talk about the poles. What happens at the poles?
Yeah, let's say the surprise at the poles, probably you're hinting at, that the messenger has identified, and I think even from the Earth, we have identified that there is ice on the poles in craters, and which you could say is surprising. On the other side, I think, if the sun is not falling really into the location it's called, it's understandable. I think what is even more surprising, that we have indications from the messenger spacecraft that the ice is replenished. So the ice which we are seeing is not the kind of 4 billion year old ice, right? It's something which is new in the geological sense, right? So not a year or 1,000 or millions but it's geologically seen a renewed ice there, which again was a surprise for everybody, and I'm not sure we have an explanation for this currently.
Yeah, so maybe Lina, I just put you on the spot. You're a scientist. Where does it come from? Where does that water ice come from at the poles of Mercury? There are a couple of theories, I know, so maybe you can talk us through those.
From what I know, I thought that, we are not really sure whether it's water ice or sulfuric acid that we observe. So with BepiColombo, what is really special is that the orbit, because we will have the planetary orbiter, it will get really, really close to the surface, and we will be able to see the northern pole and the southern pole more precisely with all the remote sensing measurement instruments, and we will be able to answer this question, I guess, whether it's really water ice or sulfuric acid, and how is it generated, or...
I guess it's either from inside with these, I've forgotten the name. What are the names of these little craters which are around some of the giant craters where it looks like there's lots of volatiles? They have a particular name on Mercury.
Hollows.
Yeah, the hollows, exactly. So it could be coming up from underneath, or you mentioned it before, exactly. Joe. It could be comets hitting the surface, for example, in the inner solar system.
Really, really big discovery if we really observe kind of volcanic activity on Mercury. So this would be really, really exciting. It was never observed before. So, yeah.
Indeed. Well, it's an exciting moment. We have a great question, which I think we might have covered briefly before, which is what instruments on BepiColombo will actually be active for this flyby? And I guess I wanted to follow up there because, of course, this isn't the first flyby of a planet that BepiColombo has done.
This is the first.
It is not.
It is not.
It's not. Yeah, it's so the first flyby. Well, I can answer this question, then Joe can compliment. The first flyby was at Earth for BepiColombo, and then the second flyby was Venus, which was in 15th of October, and that's the third flyby or the second flyby of Venus, and then we will have 6 other flybys of Mercury before the orbit insertion in 2025. And so for this next flyby, so next week, as Joe said, so we will have at least remote sensing instruments from Mercurys, and so UV measurements and infrared measurements, but also from the in situ instruments we will have. So the particles instruments will be on. We will be able to measure the ions, the ion composition, and the electron distribution as well in the induced magnetosphere of Venus, but also the magnetic field as well. We will be able to measure it. And from Solar Orbiter as well, all the in situ instruments will be on. So again, same magnetic fields, the particles, electrons, and ions, and the energetic ions. And so since both spacecraft will be at the same time inside the induced magnetosphere of Venus, but at different locations, so we can, in fact, so we have planned different focuses for this flyby. So the first part, when both spacecraft are in the induced magnetosphere of Venus, well, Solar Orbiter will be 1 day earlier than BepiColombo, but both of them will be inside the induced magnetosphere. And then at some point, Solar Orbiter will be closer to the day side, while BepiColombo is still in the night side. So we will be able as well to couple different regions inside the magnetosphere of Venus. And then the last part is when a Solar Orbiter will be in the solar wind, and this is very important because it can play a kind of a solar wind monitor while BepiColombo is inside the magnetosphere. And so we can correlate what is going on in the solar wind and how it affects all the variations and that we observe inside the magnetosphere of Venus. So yeah, I mean, I'm sure there will be enormous number of observations and results from these two flyby. I mean, it will be really, really exciting, especially that the altitude will be different as well. And we also have so Akatsuki and other space telescopes that could make remote sensing measurements as well. So yeah, it will be, we will have very busy days.
So Joe, let's jump to you, because you've got a couple of multimedia files from, Lina talked about the Earth flyby of BepiColombo, which happened roughly a year after launch. In October 2018, that was the launch. Talk us through what those sound files are, because one of them is, we've been talking about the magnetometer, but the other one, I think you mentioned it, the spring accelerometer. That's a kind of a weird thing, isn't it? Right? So on board, talk us through those two instruments and what's happened to make these multimedia files that Alex has and can play for us.
Can I make a little story out of this? I think we probably have time.
Plenty. Yeah.
Because it's quite interesting, because ESA is typically an instrument which this is the maybe not getting enough attention or so.
Italian spring accelerometer, so ESA, right?
Exactly, yeah, the Italian spring accelerometer. So let me go back in the beginning of the 19th century. There was
we haven't got that much time. We haven't got that much time. Go on.
I will hurry. There's a French chemist, mathematician, astronomer, Le Verrier. And so I think he was brought up in Caen and moved to Paris later on. And he predicted Neptune, right? He did a lot of calculations on discrepancy of Jupiter and Saturn, and he predicted there must be a different planet. He predicted actually where it could be observed, and it was observed, and Neptune was found. But he also looked at Mercury, and he also identified discrepancies in the Mercury orbit. So there is this perihelion of Mercury, which is the closest point to the sun, where Mercury is always coming back. And this center is moving slightly for every Mercury orbit. And this discrepancy is about 4 to 6 meters for every Mercury orbit around the sun. And he used the Newton's mechanics, and he said something is wrong, right? And he came up with a solution. He said, if there is another planet in this orbit, we can explain very precisely this perihel movement of Mercury. And he was looking for all his life, and other astronomers continued. He died in 70, 80. And and he was kind of convinced that he found another planet called Vulcan, right, which was between Venus and Mercury. So this was still this question, and astronomers were looking for this until someday in 1915 when Albert Einstein published his paper, the explanation of the perihel movement of Mercury using the general relativity, right? And he solved it within 6 pages. He said that's the reason why. So because Mercury is so close to the sun, so that the mass is bringing the movement into this general relativity theory. So having this said, so this is not past. This is actually, we can still use Mercury to make predictions about general relativity, about especially the beta and gamma parameters of the Nordström formalism. And on BepiColombo, we need 2 instruments. We need the radio science instrument with 2 bands, the Ka band and X band, manage very precisely to determine the center of mass and the movement of the center of mass of Mercury. There is, however, one problem. If there is any other acceleration force on the spacecraft, and it be very small, the radio science instrument cannot really disentangle this. And for this, we have the Italian spring accelerometer. There are 3 springs orthogonally, and they are moving back and forth. And any kind of acceleration, be it a CME passing along, or the difference between a fast and slow solar wind, or anything, a micrometeorite hitting the solar arrays, the ESA can measure. They have a very high precision. So, and now coming back to the audio files, ESA is also operating right now, and they're operated in the Earth and the first Venus flyby. So they're measuring all these frequencies, and we are expecting now for the second Venus fly, they can measure the gravity, the gravity increase of Venus, and then the release again after the flyby. And for the Earth flyby, one of our colleagues from INAF soundified the sound of these frequencies, right? And maybe Alex can try to play this if maybe we get this over.
Yeah. Sure thing. I have 2 files. Which one would you like me to play?
The ESA one, if possible.
The one I called accelerometer.
Okay, yeah. One moment. Okay. Well, everybody, buckle up. It's a exciting moment for Space Rocks as we go multimedia. Okay, 1 second, and hopefully you'll be able to hear something very exciting indeed. Okay.
So Alex, maybe this is already sufficient for the story. Everybody can Google this. If you go to YouTube and say BepiColombo Earth Flyby ESA, you have to know, and then you will find it. So now there was an artist, John Esposito, who is not new in the musical exploration of space. Already in 1986, he released a full album called The Nebula, with 14 tracks, all dedicated to some fascinating corners of our universe. And when he was aware and heard, actually he heard the magnetometer soundification, but I think it's kind of similar. When he heard the soundification of the BepiColombo magnetometer during the Earth flyby, he tried to reproduce the same type of sound and frequency in his synthesizer. And at this point, actually, he was able to simulate the strange modulation that you heard, and created a song, and he called it Song from the Earth, which sounds like a choral song, like a hymn from the Earth or from the planet. And I think we can play at least a little bit. And I was today in discussion with the artists, and they told me they are looking for a text to the hymn. So if anybody in the audience would take the challenge, right, to write a nice poem which actually somebody could sing to the hymn, please contact John Sposito or Mark, Alex, Lina, and me. We will forward this and take it as a challenge. And maybe now we can listen for half a minute to the sound. Maybe not sure how much time we have.
Sorry, go ahead.
Do you have that queued up, Alex?
Yeah, I have. "Song from the Earth" by John Sposito, which has been uploaded earlier, and we'll play it for a second, and we'll just see what happens. Okay, one moment. Very exciting. Okay, sorry, that's the universal sound of someone doing something. Can you hear that? Okay.
Yes. So Alex, maybe everybody got the idea now.
Indeed.
So the challenge is out, and I think any artist, right, whatever, right, sound producer, painter, whoever, right, feel the challenge, right? Send us your input, whatever you have done, right? We try to incorporate it. We are always trying to combine science and art if we can, right? It's not so easy.
I think it's such a fantastic idea, and what a wonderful moment, because I'll say, while I can't claim to understand all of the science behind what we've talked about tonight, hearing something like the accelerometer, which we were just playing just before, it does give you chills, and it does give you a feeling as well. And I guess that's what so much of Space Rocks is about. Is it's not just the intellectual response to what's out there, but also the emotional one. And it's hard not to feel something, and clearly John Sposito does as well. And so what an interesting challenge. We're going to have to put that out there and see what we get back. But no, it's what Space Rocks is all about. So thank you for that.
Yeah, it's this sonification, this turning of the invisible or the inaudible into something which we can experience is, in many ways, it's what we do in general, right? I mean, because the magnetic fields, we can't see them. I mean, anybody that's looked at a bar magnet and seen those iron filings, I mean, you're not really seeing the magnetic field, right? In the same way that you're seeing a piece of metal or a lump of wood. Although even there, you could argue that you're not really seeing that either, right? You're seeing electromagnetic waves interacting with empty space because of electric charges. But let's I'm trying to use that as a way of jumping to what we will be able to see next week, because with Solar Orbiter, in fact, all of the cameras which it uses to look at the sun, they will not be able to point at Venus on the way past because of the way that the spacecraft has to be oriented. The cameras which normally look at the sun, they can't be looking at Venus. There may be a possibility from what's called Solo High, which is the camera which looks off to the side of the sun, and that might get Venus in the shot. But with BepiColombo, we have something very different. Joe, you said that we won't be able to use the main science cameras because they're sandwiched between the MPO and the MTM, between those two pieces of spacecraft. But we have the monitoring cameras on board, which were not really scientific instruments. They're used for something else. But talk us through a little bit about what we might expect to see there, what these cameras are for, what we've seen before, and what we might get next week.
Yeah, as you said, the cameras are not science cameras. They are, so to say, kind of webcams. I would compare them with the cameras on your helmet when you go biking or skiing or so, right? Some kind of off-the-shelf equipment. We decided a few years before launch, they were not originally not really in the setup, but we decided that it's important to have cameras during the cruise phase. And the original reasoning was, with them we can see the deployment of the magnetometer booms, we can see if the Huygens antenna is moving, and but now having them in place, we can use them for outreach purposes, so to say. So we have 3 of these cameras, and 2 of them, we call them MCAM 1, 2, 3, so the MCAM 2 and 3, they will be able to see Venus. At the closest flyby, both cameras will see Venus at the same time, but not. We will be zooming in on a part of the planet's surface. I expecting that we see kind of a white image, right? I don't expect that we will see a structure because our bandwidth is very broad, and the visible part where we might look down onto the surface, I think it's not sufficient energy to excite individual pixels. So I expect we will only see bright images. But shortly after the flyby, actually shortly, I really mean a few minutes, 3, 4, 5 minutes, we will move far away enough from Venus, and also in the illuminated part of Venus, so that we will see a part of the planet in the MCAMs. And from this point on, we will continuously observe with different image repetition rate until, I think, 2 days after the flyby, roughly. I think it's closest approach plus 34 hours. And in this time, we will see Venus getting smaller and smaller and smaller. We will see a few slews that the spacecraft is doing, where we will see Venus is moving up and down, I believe, or left and right. And then Venus will kind of disappear, right? It will get smaller, and then there will be 2 pixels, and at one point it's gone. And we will be on our way into the inner solar system, on our way to Mercury.
So let's just make sure that everybody understands the expectations we have. I mean, with Bepi, as we move in from, as Lina said, we're coming from the night side. So at best, Venus is there, but it's not illuminated. So you may see nothing. When it moves into sunlight, you said see the surface. Of course, I don't think we can see the surface at all. We see the tops of the clouds, right?
Yes,
these incredibly dense, thick sulfuric acid clouds. And and it may just be so bright. These cameras are not built for this purpose. It may just be so bright that basically it just saturates and goes completely white. It's kind of what we saw last time, right, at the last Venus flyby. You saw Venus, but it was
Yeah, indeed. I think the point is close to the surface. We will not be overexposed, or we do not expect to be overexposed. But if Venus is getting, so the full Venus disk, so the atmosphere, right, is getting in our field of view, we will be overexposed. Okay. We let's say we experimented in the last 6 months quite a lot with instrument settings, and we changed internal resistor settings in the camera, right, to see if we can move a little bit to the left and the right of the dynamic range. We tailored this for the flyby, so to say. So we have tailored the instrument settings, and we did tests in the past month. However, I don't really expect we will see any structures. I don't expect we will see structures in the cloud or so. We are not really sensitive enough.
And again, these are black and white cameras. They don't kind of have a filter. They just let all the light in. So, I mean, it's going to be really cool, because the thing I love about, we've seen this with other spacecraft, the Chinese spacecraft at Mars, with Rosetta, of course, at the Comet, where you can have the spacecraft in the picture with a planet as well. I think that makes it really visceral, right? It ties it together. This is a human-made object. hundreds of millions of kilometers away from the Earth. Yeah, I think so. It's on the other side of the sun at the moment, right? So it's a long way away. And you just said that crazy thing. We've been playing with the instrument. It's like, sorry, how do you play with the instrument? It's over there. It's not over here. Of course, it's software that you're tuning things. But before we finish this evening, I wanted to then move on. So we've got these two spacecraft. This is not their destination. This is a waypoint. You mentioned moving into the inner solar system. So let's talk about Bepi first. What happens next? Because this is not the last thing at all that happens in 2021, right? There's another really, really exciting event coming up not very long after.
Yeah. Maybe an interesting fact is, one astronomical unit is the distance Sun-Earth. Venus is at 07. Mercury at let's say 03 to 04, right? We will fly this distance now in less than 3 months. Right? It's a huge distance. We have a huge velocity of the spacecraft. I'm not now really sure of the number. I think it's kind of 27 kilometers per second or something. I might be mistaken there. We have a huge velocity. We are flying extremely fast. And we will reach beginning of October. We will have our next flyby and the first flyby of Mercury. And also the Mercury flyby will be very close to the surface. Now this Venus flyby is a first for BepiColombo because it's very close. The Earth and the first Venus flyby were from quite some distance. Now we're really going to 500 kilometers. And I think the Mercury flyby is, I don't want to say something wrong. It's closer to the surface than 500 kilometers.
Yeah, about 200 kilometers.
200, yeah.
So again, Lina, talk us through that, because we've done this August, then in October we have that next flyby. We're at Mercury. Hey, done, right? All over.
No,
we're at Mercury. No, I know. So tell us why not. Because Joe said already, we're going so fast, right? Now we have to somehow slow down. And that's what all these Mercury flybys are about.
Yeah. I mean, well, just to compliment, I mean, we will be very close to the surface of Mercury. And even, if I'm not wrong, even Messenger did not flew in this region at this distance. So it will be very, very critical and very important, event in October. And we won't, why this Venus flyby was important. First, to prepare for this flyby was extremely important to have all the instruments ready and to prepare the commands, because we won't have the time between August and October to modify any command or so everything had to be ready for this flyby. So everything, so the first Mercury flyby, that will go very well. And also, from as scientists, we will be extremely busy after, starting from next week, and we won't have the time. We will, we will be, working continuously and even after the flyby of Mercury.
So we have the first one in October, and then we have a total of 6 Mercury flybys. So Joe, when do we finally get into orbit after we've managed to slow ourselves down? Each one of these flybys is important to get us slow enough, if you like, to be captured by Mercury, even though we have to use a rocket motor as well at the end to manage that. So when do we finally arrive at Mercury and go into this 400 kilometer, 1500 kilometer orbit?
The real goal is, let me start on, if you fly to the Lagrange point at the Earth, right, where Soho, for example, is, the pulling from all objects in the solar system basically is 0. So if you manage to go to this point, you can park your spacecraft there. If we manage now to get to such a point at Mercury with a very low velocity, and then do the right maneuver at this point, we move ourselves into the orbit of Mercury. So all of these activities will happen, let's say, at the end of 2025. In December 2025, we will go to this point around Mercury. And at this point, we have to do a lot of maneuvers to get into orbit. First, we have to release the transfer, the transfer module is releasing the European orbiter and the Japanese orbiter. And then the European orbiter has to bring the Japanese orbiter in its orbit. So flying in a stack with 2 spacecraft, right? When we release the Japanese orbiter in its orbit, we move the solar protection shield out, fire it away, and then we reduce our orbit to go into the orbit that we need for the European orbiter, for MPO. This will probably be reached in March, April timeframe of 2026. This will be a very, how should I say, a very delicate area. The ESA colleagues, they're probably sweating already right now. There are many maneuvers to be done, and everything has to work basically, right? This has to go right to really go in time into the right orbit. So at the end of 2025 to April 2026, this will be a very hot period, will be very exciting. And then we will start our nominal operation. So the Japanese orbiter will start a little bit earlier, I think in January, beginning of February. And the European orbiter will start then in end of March, beginning of April to do the nominal science operation. Then for us, the mission is starting.
Right. I mean, just as a reminder to everybody, you mentioned Akatsuki earlier on. Of course, Akatsuki, when it went to Venus some years ago, it failed with its trajectory correction to get into orbit around Venus the first time, and then went off in this long loop out through the inner solar system and came back years later, and then managed to get into orbit the second time. So yeah, let's hope it all works the first time, but the skills required to make all of these maneuvers work and kind of getting it right, exactly the right moment is remarkable.
Yeah,
indeed.
And then, so just before we move on, Alex, I know it's time, but we should finish up. But I just want to ask Lina whether, between us we can talk through what Solar Orbiter's doing, because of course this is not the last time that Solar Orbiter will be at Venus, because Venus plays a very special role in the Solar Orbiter mission. It will keep coming back repeatedly. Yeah. So maybe you can tell us a little bit about what Solar Orbiter is going to be doing.
Yeah, exactly. So using the gravity assist from Venus, so this will first it will make Solar Orbiter gets closer and closer to the sun, but also, and more importantly, it will enable the spacecraft to incline the trajectory from the ecliptic plane, is the plane where all the planets rotate, and so Solar Orbiter will be able to observe the polar regions of the sun for the first time, and so to observe actually the sun from completely different perspectives. So yeah, I mean, with all these missions, I mean, it will be very exciting measurements. I mean, from very close to the sun up at different distances from the sun. So
right. So again, this is not the last time we'll be at Venus, and we are also building new missions to go to Venus. We know, that NASA has selected 2 missions, and so has the European Space Agency. So within the next 10 years or so, this kind of is a precursor to 3 dedicated new Venus missions, which will be going to study Venus. So we'll be talking to people about the Venus science in much more detail, which will be really exciting. So Alex, sorry, it's 10 past, it's quarter past. It's unless you had some more questions from the audience at this point.
Yeah, some great comments being made, but I suppose fundamentally, it's just such an exciting moment. There's so much happening next week. I suppose it is just a few days away now. So it really is just the final countdown until this all happens.
Oh dear. Yeah. Sorry, if you don't know, it's the famous song by the band Europe called "The Final Countdown," and there is a lyric, and Alex has mentioned. So Alex is going to have to sing it now. The part about Venus.
Well, we're headed to Venus. Is as far as I'll go. So many light years to go, and things to be found. I'm going to say, Lina, what an absolute pleasure it's been to say hello to be joined by you. We would love to check in with you again soon, because this is an absolutely fascinating area of research, and it's been so fantastic to be enlightened thanks to you. And before you go, and I suppose it's quite fitting because we actually mentioned Vulcan tonight, that we do this. Mark, I hand it back to you.
Yeah, so this planet Vulcan, this mysterious planet Vulcan, of course, is a part of the inspiration for the Vulcan salute, which is Spock from Star Trek. So we all have to do this now, Lina, so I know it looks challenging. So this is the Vulcan salute, which is live long and prosper. So that's for space. And this is rocks, space and rocks. I think we've actually lost Lina. No, there she is. No, she's back.
There she is. There we go. All right.
So, you're being the real. Okay.
I'm not.
So, Space Rocks. Thank you thank you very much, both Lina, Joe. It's been brilliant, and as Alex said, we'd love to have you back on when we hear more about what happens next week. I mean, we'll all be watching, and Joe, everybody's involved. I mean, getting some of that stuff out and. Witnessing something quite interesting as we've discussed this evening. Just 2 spacecraft, 33 hours apart at the planet Venus.
Indeed. Thank you so much, and we'll be in touch very soon. Be well.
Thank you very much for having us. Thank you.
Bye, everybody. It was fun tonight.
Bye-bye.
Thanks, Joe. Thanks, Lina. Bye-bye.
And Mark, I have to say, thanks so much to everybody in the chat who is also doing the Space Rock salute by emoji, which is fantastic. Thanks so much to everyone who's joined us and asked some really fantastic questions. That's just absolutely lovely when you kind of feel like, well, you walk away having understood the universe just a little better, which is always fantastic, Mark.
Absolutely. I mean, look, 2 great guests talking about something, again, as if it's an everyday thing. Right? This is what we do. We measure particles in the magnetopause, around the magnetosphere around a planet 100 million kilometers away, and then we command something that it can fly 200 kilometers over the surface of Mercury. This is remarkable stuff, and I know it's a little bit everyday to some of us in the space business, but it's teamwork in the end as well, right? And Joe and Lina representing hundreds of people on both missions, and all the mission operations, the science operations people at ESAC in Spain and ESOC in Germany, the science guys at ESTEC, and the science community on the outside, and all the industry that made these things in the first place, right? I mean, we wouldn't be there without hundreds and hundreds of people putting all this together.
Absolutely. And, just like let it never be said that we take for granted just how difficult it is to do these things. I mean, it's so strange. But as an observer, from the outside, what I always find remarkable is how matter of fact people are about truly extraordinary feats of engineering, of cooperation. And, this is mind blowing stuff when you really think about it. And so let us never take it for granted. It's hard stuff. Space is hard. What's happening next week is absolutely extraordinary. So, so as ever, an absolute pleasure to spend the time with you, Mark. I'll be watching along with everybody else. And the arrivals, I suppose, are 33 hours apart, aren't they? And so
I mean, just to get people back on time again, it's in the early morning hours. Sort of around 6 o'clock in the morning, European time for Solar Orbiter on the 9th of August, and then in the mid-afternoon, sort of 4 o'clock or so. All the times are on our website. You can get the more precise times on the 10th when Bepi flies past. And again, we'll be doing updates, telling people what's going on, it's working and so on. Get those images back in the day following or so and start releasing those to give a bit more of a feeling for what actually happened for BepiColombo. And then they go on their way. But we'll be at Mercury with BepiColombo just a few months later, which is that's the real target, and that's really exciting as well.
Indeed. And if you want to stay in touch with Space Rocks, obviously follow us on our socials, or just go to our brand new website at spacerocksofficial.com. Sign up for the newsletter. We have a weekly mission update, which we send out to let you know about future episodes of Uplink and everything else happening in our world. So that's spacerocksofficial.com. Mark, as ever, an absolute pleasure.
And we hope to be back next week, so we can talk about it then with our guests next week, who we'll announce in the next day or two.
Indeed. Very good. We'll see you soon, my friend.
Thanks, everybody. Bye now.